Jesus. Okay. All right. Exactly. What's our answer?
I don't know.
What? You don't know? Why don't you know? Cole, what do you got? 15. It's E. The answer is E. The answer is E. How? What you said? Yeah. What'd you think it was? Nothing?
I didn't have an answer.
All right. 5/2. Now, I think some people end up getting this just because some say, oh, I'll just multiply 5 times 3 and 2 times 2, 4. Now, that might work. I honestly don't know if it works for everything. That would be a little bit of a test that I have to look into. But make the y's the same. Make the y's the same. Okay? Well, how can I make them the same number? Well, what do 2 and 3 both go into? 6. So multiply this one by 3 and 3. And that gives me 15/6. And then this one is multiplied by 2 and 2. And that gives me 6/4. So hopefully it makes sense here. So if you got 15 is to 6, 15 to 6, and then 6 to 4. So you got x, y, y, z. So the ratio of x to z would then be 15 to 4. Hopefully that makes sense in terms of that. I'd have to look a little bit further. We can just multiply straight across and see if that'll hold. Okay, I think it will, but I'm not positive. All right, homework questions. I got most of yours. If you submitted late, I still got to look it over. But homework questions. As we take a look at those. 38 should be the following: -2, 1, 1, 1 plus I, and 1 minus I. Get to that one. All right. That does not factor in that. Quadratic formula. Okay. For that one. Now, for 38, here's what's going on. And most everybody was okay. Couple issues. And I can't remember if they were in this class or not. But the graph looks like this. So it hits at -2 and it hits at 1. Well, then it hits at 1, it bounces there, so it's a root twice. So you got to use that 2 times in the synthetic division. So you got to use -2, you got to use 1, and then you got to use 1 again in order to get that all the way down to quadratic. Okay, for that one, and then you'll be good. All right. Anything else? All right. We're going to go over section 3.6. I'm going to have guided notes here for you in a second. We're going to talk about rational functions, talk about some vertical asymptotes. We're going to talk about some horizontal asymptotes. But before we do that, I want you to graph this equation without just graphing it on your calculator. You can use your calculator for some computation, but don't type it in and graph it yet. How do you graph something when you don't know what it looks like? Table, plot points. Pick some numbers, plug them in for x, see what you get back for y. Okay? And let me hand out your guided notes.
Let's see.
All right, so at least get an XY axis down, plot a couple points, see what you think it looks like.
So from negative starting with negative pi root 4, I'm going to add pi root 2. I refer, when I take a fourth of that, I refer to that as my maximum. Okay? So I'm taking negative pi root 4 plus pi root 2. I'm going to add these terms. What do we have to have at max? Okay, so I'm going to do this here. So my next mark over is going to be at 5 to 4. Starting point.
Right.
One, two,
Points there. All right, now once you got a few points, go ahead and graph on your calculator and see if it matches up with what you got.
Don't look at that.
okay, yeah, I do, right, yes, recall. We would be adding that to our 4.
If you might need to put it in parentheses, the numerator and denominator, especially if it doesn't like convert it to a fraction automatically. Oh, no, that's not it. Put in parentheses. There we go. All right, got it. All right, good. All right, good. All right, how many pieces are on that graph? Okay, when you take a look at that, should have 2 pieces right there, a piece on the left and then a piece on the right. Because what happens at 3? What happens when you plug in 3? Okay.
Undefined.
It's undefined, doesn't exist, because 3 minus 3 is 0. So that is what we call vertical asymptote. So at 3, okay, it doesn't exist. And what it does is it's going to split it into 2 pieces. Now on the left, most of you probably plugged in like -2, -1, 0, 1, and 2, or plugged in numbers similar to that over here. And what do we get when we plug in -2? Is it 1? -2 is 1. I think 0 is like 1/3, right? What do you get when you plug in 1? Negative 1/2. And then how about 2? Negative 3. All right, what's happening way out to the left? What's happening way out to the left? As it goes like to negative 4, negative 6, negative 8, and then to negative 10. So where is it going? So if I take a look at my table, where's it at negative 10? It is at 1.6. Okay? 1.6. All right. Is it going to keep going up and go to infinity? It's going to keep going up. It's going to keep being bigger and bigger and bigger and bigger. How can you use your table to tell? Let's take a look at what happens when you plug in some smaller numbers than negative 11. Now, you can scroll, but that's going to take forever. Go to second table set. And this tells you where your table starts. The delta table tells you how fast it goes up. So let's just start at negative 10. And I'm going to go by tens and see what's happening. As I go back to my table, and at negative 10, it's 1.6. At negative 20, it's 1.78. Negative 30. Okay, negative 40. Where's it at negative 100? 1.95? Okay, where's it at negative 200? And that's going to be at, will it stop in time? Nope. I'm going to go negative 3. Where am I going? I got 1.98. Where's it heading? Where's it heading? Okay. And if we're not sure, plug in some bigger numbers. I can change my table. I'm going to do second table set. I'm going to go to negative, 5,000. And I'm going to go up by 100. And what's that going to be? Oops, I didn't want to hit that. I wanted to hit second table. 1.999. Okay. It's heading to the number 2. Is it going to get there? No, it's going to get really, really close, but it's never going to get there. That is a horizontal asymptote. Okay. So if you take a look, that is going to, it's not going to infinity. Okay, it's capped out at 2. If you look at the other piece on the other side, I think 4, if you plug in 4, you get 7. And I think if I plug in 8, I get 3. But it is also going towards 2. It's going to level off and it's going to approach 2 because I can plug in, I can switch my table set and I can make that positive. I'll just go 2,000 since I hit a 2. And take a look at the table. And it's 2.0025. It's just a little bit bigger. Okay, on the one side it's a little bit smaller than 2, and the other side is a little bit bigger than 2, which you can see because of the where the graph's coming from on both sides. So that's a rational function. They come in a lot of different shapes. A lot of different shapes for that one. But we want to be able to today identify what vertical asymptotes are and horizontal asymptotes. All right. All right, now we're on the guided notes. Bless you. You will be able to graph that hopefully easily by the end of the week. Okay, hopefully pretty easily. All right, now here. Okay, I think in that definition at the top, a function f that can be expressed in the form f of x equals n of x divided by d of x. Okay, the numerator and the denominator are both polynomials. Those are polynomials what we've been dealing with this whole time. Okay, whole number powers, you cannot have radicals. D of x cannot be 0, and they just call it the 0 polynomial because then the whole thing would wash out. But it's called a rational function. The domain consists of all of the x values that do not make the domain equal to 0, okay, which you're pretty familiar with. All right, a little bit here on notation. This is the definition for vertical asymptote. You know it when you see it, but it's a little bit hard to define initially. All right, it says the absolute of f value of f of x goes to infinity. Well, that just means it can go to positive or negative infinity. They just use the absolute value to make it a little bit easier to write. All right, as x approaches a with a little plus sign above it, or x approaches a with a little minus sign above it. The plus sign means it's bigger than that a value, and the minus sign means it's smaller than the a. Let me go backwards to what we're talking about here. So for here, as x approaches a, let me not use a, let me use 3 because that's our asymptote. That means as x approaches 3 from the left, smaller than 3. So that's like starting at 0, 1, 2. As I start plugging in numbers that get closer and closer to 3, where's f of x going for this one? F of x is going down. F of x is going towards negative infinity, approaches negative infinity. As x approaches 3 from the right, okay, as I plug in numbers bigger than 3 and I get closer and closer to 3, where is it going? F of x is going to positive infinity. So that's what the little plus sign means, and the minus sign to the right, from the right, and from the left, okay? Now you got those pictures there. It's a little bit fuzzy, but this is what it's saying. Same thing I just talked about. As x approaches a from the left, f of x is going to negative infinity. As it approaches it from the right, f of x is going to positive infinity. And you got the different options here. Now here it's flipped. It's going to positive infinity from the left, negative infinity from the right. And then the other two, they're both either going to positive infinity or negative infinity. So this one here, okay, whoops. Okay, that first one there, they're both going to positive infinity, and the second one, they're both going to negative infinity. Okay, all right, identifying vertical asymptotes. So you need to just be able to look at an equation without graphing it, tell me where the vertical asymptotes are, and then also identify the domain. Vertical asymptotes, where does the denominator equal 0? Equals 0 at 1. So that's your vertical asymptote. So your vertical asymptote. And it's always x equals the constant. You just can't say 1. You have to say x equals 1 because it is a line. Okay, it's a line. What's our domain? Everything but 1. Domain. Negative infinity to 1. Union 1 to infinity. Okay, for that. Negative infinity to 1. Union 1 to infinity. All right. Now your numerator does not directly affect the vertical asymptote. Okay, we do not use it to find it. We just find where the denominator equals 0. We do not, where the numerator equals 0, that's a point on the graph, but it is not an asymptote. All right, for B, we want to know where it equals 0. You better factor. And that'll factor into x minus 4 times x minus 2. All right, horizontal asymptotes, or not horizontal, vertical, you have 2 of them. Because x cannot equal 4, x cannot equal 2. Okay, so our vertical asymptotes are x equals 2, x equals 4, our domain, negative infinity to 2, union 2 to 4, union 4 to infinity. Okay, for that. All right, copy down this third one. I want you to think what you think it is, and then graph it and see if it confirms or rejects kind of what you're thinking. So take a look at h of x equals 2 x over x squared plus 4. All right, think about it, then graph it on your calculator. If you need to change your window, go back to the original window, Zoom 6. Now it's really close to the axis there, so you might want to zoom in. Well, I wouldn't hit zoom in, I would change my window, but that's just me. So 2x divided by x squared plus 4. And initially, you don't get a great look at it, but it's really close to the axis. So I'm going to change my window. And I'm actually just going to go -1. I think I can do this. -1 to 1. I'll make that 0.5. See what happens there. Okay, so right there, there's a lot going on at that point. But is there any asymptotes? No, there's no asymptotes because the denominator will never equal 0. X squared will always be a positive number. We're adding 4 to it. Now, if you solved it and said, all right, x squared equals -4, you got plus or minus 2y. All right, those do make it equal 0, but they're not on the x-axis, okay? This is the real number system. There's no complex numbers. So at this point, your domain is all real numbers, and there is no vertical asymptotes. So a little bit of a trick question. Domain, negative infinity to infinity. Vertical asymptotes, none. Okay, none for that. All right, how about D? Take a look at this one. Another little bit of a, I don't know, I guess a tricky situation here. All right, f of x equals x squared minus 9 over x minus 3. All right, the numerator does not determine where the vertical asymptotes are, but they can affect it because what can we do with that numerator? X squared minus 9 factors into what? Factors into x minus 3 times x plus 3. Factors into that. Now what happens to the x minus 3s? Those will cancel. So those cancel. And so really what you're left with is f of x equals x plus 3. All right, now graph the original function. Graph the original function. See what that looks like. And just keep it as x squared minus 9 over x minus 3. I'm going to change my window back. And let's see, y equals x squared minus 9 divided by x minus 3 and graph. Straight line. Do you see vertical asymptote? There is no vertical asymptote there. But is the original problem, what number can't I plug into the original function? Can't plug in 3. Now, I got to change my table here. I'm going to go back to 0 and go up by 1s. What does it say at 3? It says error. It's undefined at that point. There's no vertical asymptote. Now, this is one of those weird cases where the graph, although you can't see it on your calculator, there's a hole there, okay? Now, one of the Zoom ones will let you see the hole. I don't know if it's Z integer or there's another one, Z square. I'm not sure which one, but it'll show up. But in this case here, there's a hole at the graph. Now, our domain is everything but 3. You still get undefined when you plug in 3. So it's negative infinity to 3 union 3 to infinity, but there are no vertical asymptotes. Okay, no vertical asymptotes. Because when it cancels, that takes out that vertical asymptote, it just makes it that line, although there will be an undefined point at 3, which corresponds to 0.36. So there's a hole in the graph, but there are no vertical asymptotes. All right, horizontal, different story. Yeah, I forgot to hit one-sided to two-sided on the copier. So sorry about that. Okay, f of x goes to k, which is just a constant. Okay, and that's the line y equals k is called a horizontal asymptote of the function. Okay, if as x goes to infinity, f of x goes to this k value. And as f of x, x goes to negative infinity, f of x goes to k value. All right, one huge difference. Unlike vertical asymptotes, a graph can cross, touch, hit a horizontal asymptote. It doesn't all the time, but it can. The earlier example we had, it did not hit it. It came close, but it didn't hit it. But there will be situations where it does just go straight through it. But the key is it won't do it way to the right and it won't do it way to the left. So here's what you gotta do is you gotta think, what happens when I plug in really big numbers? Does it go towards something or does it not? Oh, what function do we have in there? We had x squared minus 9 over x. Oh, that ended up being a line. Okay. All right, so for that first one, find the horizontal asymptote, if any, of the graph of each rational function. All right, here's what you got to think. As x gets really big, does f of x approach any number? I shouldn't say equals. It's not really equal. All right, you plug in bigger numbers. So you got 1 over 10, you got 1 over 100, you got 1 over 1,000, you got 1 over 1,000,000. Okay, really, what's that value getting close to? It's making sense? Jay? Zero. It's getting close to 0. And as x goes to negative infinity, it's really going to be the same thing. F of x, it's just going to be a negative value. So my horizontal asymptote is y equals 0. Gets close to 0. All right, not that you need to, but here, if I just graph it real quick, 1 divided by x. Okay, you see it goes along that line and it gets really closer. All right, actually, I want you to think, instead of a 1, what if I made it 1,000 over x? As x gets big, where's that heading? As x gets big, where's that heading? All right, let's see what it looks like. I'm curious here. 1, 2, 3, delete, divided by x. I don't know if I'll be able to see it. Window, table. All right, let me go negative 20 to 20. I'm guessing negative 1,000 to 1,000. Make that 100. Where's it going? It's going to 0 again. It really doesn't matter what this number is. You're always going to be able to go to infinity, which is going to dwarf it. So even if it's like 1,000,000 or 10 million, x is getting infinitely big. It will always go to 0. If this is any number over x, it will go to 0. Okay, even if it's a big number. All right, on there. Now, this case here is not as obvious because we got another x running around in there. And let me explain how to do this one. Okay. All right, the little trick here. Now, you might be able to think about it mentally and figure it out. But there's a little bit of a trick. Find whatever x is to the largest power. And here it's just an x. Divide every term by that. So take 3x divided by x. Take x divided by x. And take 7 divided by x. Okay, so we're going to do this in all cases. Find the highest degree x, and then divide everything by that. All right, simplify now. 3x over x, what does that simplify to? It simplifies to 3. X over x is a 1. 7 over x we can't do anything with. All right, now let x go to infinity. What will happen to this expression as x gets really big? Well, there's only one term with an x. The 3 doesn't get affected, the 1 doesn't get affected, but what happens to 7 to infinity? Or 7 divided by infinity? Where's it heading towards? It's heading towards 0, okay? So now this just really becomes, think of it as 0. You might as well, because we can make it as close as we want. This is really 1 plus 0, which is just 1. So this whole thing becomes what? 3. That's our answer. So f of x equals 3 as what? X goes to infinity. Well, it doesn't technically equals 3. F of x goes to 3 as x goes to infinity. So that's my horizontal asymptote. So my horizontal asymptote is y equals 3. What will my answer be when I plug in big numbers? Well, we see what happens to send anything divided by that value. It goes to 0. All right, let's use the same concept on this one. Copy that down. All right, g of x is 7x squared minus 4 over 2x squared plus 9. What's my highest degree x squared? Or my highest degree of x is x squared. So divide every piece by x squared. And then 2x squared over x squared plus 9x over x squared. All right, simplify that. Reduce everything that can be reduced. Well, 7x squared over x squared is 7 minus 4 over x squared. 2x squared over x squared is 2 plus 9 over x. All right, now or think about x going to infinity. X is going to blow up, get real big. Well, what happens to the 7 and the 2 are not affected, but what's 4 over x squared? That's got to head to what? That's got to go to 0, and 9 over x has to go to 0. And so when we're done, f of x is going to go to 7 over 2, whatever those whole numbers that are left. That's your horizontal asymptote. So my horizontal asymptote is y equals 7/2. Okay, 7/2. All right, now there's one more, not a trick one, but one that's just a little bit something different happens. Take a look at this one here. h of x equals 2x plus 5 over 3x squared. Okay, biggest x value is x squared. Divide each piece by x squared. 2x over x squared plus 5 over x. 3x squared over x squared. So we're just reducing everything, dividing everything by x squared. All right, now that gives me 2 over x, because that reduces, plus, oh, that should be an x squared, sorry, plus 5 over x squared. And the denominator reduces to a 3. All right, let x go to infinity. Let x get really big. All right, what's that whole thing going to end up approaching? Okay, I heard it. 0. Because both pieces of the numerator are heading to 0 because they're being divided by a huge number. So this is going to head towards 0. This is going to head towards 0, but even a little bit faster. But in the end, as you keep getting bigger and bigger, eventually you're going to get there. So this equals 0 over 3. So that means h of x approaches 0 over 3. So that's your horizontal asymptote. Y equals 0 is my horizontal asymptote. Okay, for that. All right, vertical asymptotes you're a lot more comfortable with. Horizontal asymptotes, you're not quite. Now, we went through this little procedure here. We're going to try and figure out a way that we don't have to do that every time tomorrow. Okay, it's not that difficult, but I wanted to at least build it up today. So page 399. On 5 through 8, those first ones are actually on the bottom of the page. Don't get tricked into doing. There's some on the top. They're not homework problems. They're actually other examples from earlier in the book. Do not do the ones on the top. Do the ones on the bottom.